Project Mercury. In the heat of the Cold War space race, the United States needed a bold answer to early Soviet successes. That answer was Project Mercury, America's first human spaceflight program. The mission had a fundamental question at its core. Could a person survive and function in the hostile environment of space? To find out, 7 military test pilots, the legendary Mercury 7, were selected to fly. Their spacecraft were tiny, one-man capsules, so cramped the astronauts famously said they didn't get in the capsule, they wore it. From Alan Shepard's 15-minute suborbital hop that made him the first American in space, to John Glenn's 3 grueling orbits of the Earth, each flight was a nail-biting test. Ultimately, Mercury was a resounding success, proving that humans could indeed operate in orbit and paving the way for the more complex missions that lay ahead. Project Gemini. Project Gemini served as the crucial bridge between the pioneering solo flights of Mercury and the ambitious lunar missions of Apollo. The name Gemini, Latin for twins, reflected its new 2-person capsule, but the program's true purpose was to be a dress rehearsal for landing on the moon. Gemini missions systematically mastered the complex skills required for a lunar journey. For instance, astronauts needed to survive in space long enough for a round trip. The crew of Gemini 7 spent nearly 14 days in orbit to prove it was possible. They also needed to work outside their ship, a feat first accomplished by an American during Ed White's famous spacewalk on Gemini 4. Most critically, the program perfected orbital rendezvous and docking, the delicate space ballet of 2 vehicles meeting and connecting, a maneuver that would be absolutely essential for the lunar module to reunite with the command module on the way home from the moon. Apollo Program. Born from a bold challenge to land a human on the moon and return them safely before the end of the 1960s, the Apollo program stands as a monumental achievement in human exploration. To accomplish this, engineers developed the most powerful rocket ever built, the massive Saturn V, which stood taller than a 36-story building. This behemoth launched a specialized 2-part spacecraft, the command module, which served as the crew's home while orbiting the moon, and the delicate lunar module, designed for the sole purpose of descending to and ascending from the lunar surface. This incredible system worked, culminating in the historic Apollo 11 mission, where Neil Armstrong took his famous one small step. But the program was more than a single moment. Over the course of 6 successful landings, 12 astronauts would walk on the moon, conducting scientific experiments and even driving the lunar roving vehicle across the dusty terrain, forever proving that the seemingly impossible was within our reach. Skylab. Imagine taking the upper stage of a giant Saturn V rocket, launching it into orbit, and then turning it into a house. That was the brilliant recycled concept behind Skylab, America's first space station. Its primary mission was to see if humans could actually live and work in space for months at a time, not just the quick trips of previous programs. Inside the workshop, which was as spacious as a small apartment, 3 different crews of astronauts set endurance records, with the final team staying for 84 days. They became the subjects of intense medical study, while also using a powerful solar telescope to study the sun, and even observing how spiders spun webs in zero gravity. The station's life began with near disaster when a heat shield ripped off during launch, forcing the first crew to perform a daring spacewalk to deploy a makeshift sunshade and save the entire program, proving not just that humans could live in space, but that they could solve complex problems there too. Space Shuttle. The Space Shuttle program revolutionized human spaceflight by creating the world's first reusable orbital spaceplane. This incredible vehicle launched vertically like a conventional rocket, strapped to a massive external fuel tank and 2 powerful solid rocket boosters, but it returned to Earth by gliding to a runway landing just like an airplane. This unique capability transformed it into a versatile workhorse for low Earth orbit, acting as a combination science lab, satellite deployer, and heavy-duty construction truck. It was the only vehicle that could carry the enormous components needed to build the International Space Station, hauling up modules and truss segments piece by piece. The shuttle also famously deployed the Hubble Space Telescope and, in a feat no other spacecraft could manage, returned years later to perform critical repairs and upgrades. For 3 decades, this remarkable fleet served as the backbone of crewed missions, fundamentally changing humanity's ability to live and work in space. International Space Station. The International Space Station is a sprawling laboratory the size of an American football field, circling our planet at 5 miles per second. It represents one of the most complex scientific projects ever undertaken, a peaceful partnership between the United States, Russia, Europe, Japan, and Canada. Aboard this orbiting outpost, astronauts conduct experiments in the unique environment of microgravity, something impossible to replicate on Earth. They study how the human body adapts to long-duration spaceflight, test new technologies, and even grow plants, all vital research for future missions to the Moon and Mars. As a permanent human home in space, continuously occupied since the year 2000, its crew experiences 16 sunrises and sunsets a day while serving as a crucial stepping stone, teaching us how to live and work off-planet for the long journey ahead. Commercial Crew Program. With the retirement of the Space Shuttle, NASA needed a new way to get its astronauts to the International Space Station without relying on foreign rockets. The solution was a radical shift in thinking called the Commercial Crew Program. Instead of owning and operating the spacecraft itself, NASA became a customer, essentially hiring a taxi service to low Earth orbit from private American companies. Under this model, companies like SpaceX with its Crew Dragon and Boeing with its Starliner were tasked to design, build, and launch their own astronaut transportation systems, all while meeting NASA's rigorous safety standards. This competitive approach not only restored America's ability to launch its own crews from U.S. soil, but also freed up the agency to focus its resources on pushing the boundaries of deep space exploration, aiming for the Moon and beyond. Artemis Program. Named after the mythical twin sister of Apollo, the Artemis program represents humanity's return to the Moon, but with a bold new vision for the 21st century. Unlike the short flags and footprints missions of the past, this new chapter in exploration aims to establish a long-term, sustainable human presence. A key part of this is the Gateway, a small space station in lunar orbit that will act as a staging point for missions to the surface and into deep space. The program intends to land the first woman and the next man on the lunar South Pole, a region believed to hold vital resources like water ice. Ultimately, everything learned and built on and around the Moon, from the powerful Space Launch System rocket to techniques for living on another world, is a crucial practice run for humanity's next giant leap, sending astronauts to Mars.